What's up, guys? And today we are going to start a new series of videos that is about the fundamentals about Rust programming language. I just record the first section of the using Rust programming language to create the thread pool, but I think a lot of the people, especially the people who have not been working with a C++ or C or other compile language, they just don't know how to approach Rust in the appropriate way and thinks Rust is the like really hard language. But so today I'll just do do a series of videos from scratch to help you understand Rust in the easiest way that I have learned it by myself, and it is absolutely useful for me. And if I have said anything wrong, please point it out in the comment section, and I would like to hear that. So for those who don't have an IDE or who do not use Rust Rover or VS Code or some kind of stuff, I just recommend use the Rust Rover, which is the Rust IDE by JetBrains company. If you guys know PyCharm, it's by the same company and just basically looks the same thing. And if you're using macOS, just click File and New Project. So I'll create it right here. Rust. I'll call it tutorial. And by the way, all of the source code I just do it today. I write today is going to be on a GitHub repo. I'll leave the link in the comment section, and just be sure that it's a binary file, and just click binary instead of library. I'll explain the difference later. It's not empty. I'll just create from existing source. Okay, so SRC, and if you take a look at this, the SRC we have a SRC folder under the tutorial folder and cargo.toml, and these are the only two things you're going to take care of. If you open the cargo.toml, it has two things. The first thing is the package, which is the project you created. You can see it has a name of tutorial, version, and edition. And right here you have a dependencies. These are just the external crates you are going to use in your projects, and it will just automatically handle other things for you. For example, one of them, I just, okay, no, all right. So one of the crate that we always use to do the error handling is called anyhow. And for example, if you want to add that, you can just use cargo add anyhow. It's really easy. And by the way, cargo is the crate management crate manager. I think it's called crate manager for Rust. And yeah, it's something like npm for JavaScript. If you guys write JavaScript before, so it's like the npm for Rust. So if you do cargo and anyhow, you can see right here. If you already do that, anyhow will be automatically added to the dependencies and cargo. So yeah, so if you guys learned JavaScript before, it's just like the package.json for Rust, the cargo toml. Yeah, and we can take a look at the main.rs right now, and fn main, we have print ln right here. Okay, so this is the easiest code in Rust programming language, and it's really easy to understand since fn just means a function, and main function is a really special function that the computer knows it's going to start the whole thing right here. So this is the what we call the entrance of the whole code base, right? So we have the main function right here, and right here we're just printing the hello world. Sorry. So the print ln right here is a macro. I'll also talk about the macro, what a macro is later. There are three kind of macro, and it's really complicated, and I think it's the most complicated part, one of the most complicated part in Rust programming language, but we'll talk about that later. So we can compile it for now, and yeah, you can see hello world right here. That just means we already compiled it, and it just runs the whole binary file for us. And so today we are going to, the first thing we're going to take a look at is something like some easy types. Like there are a lot of types in Rust programming language. The most, if you guys take the, I've have like experience with computer before, you guys know int, right? It's a 64, it's a 64-bit. This this is like 8 bytes. By the way, a byte is just 8, a byte is 8-bit, right? And a bit is just a 0 or 1 integer. So 8 byte is just like 64 0 or 1 integer that can represent a lot of things using UTF-8 or just, yeah, that kind of like encoding style. And we have int, we have short, which is 2 bytes. We have like a char, which is 1 byte, and we have 1 byte. We have like a string, and we have vector, all that kind of stuff in C++, and in other programming languages like Python. But in Python or in JavaScript, you don't have to understand it that deep, since it doesn't require to have a type system. But yes, what we can do right here is to just convert all these things into Rust, right? So for number, Rust has a more clear type system, which you can think of in this way. Like we have I16, we have I32, we have I64, and we have I don't think we have I8, but let me try that out. X I8. Oh, we have that type. I haven't used it. I haven't used it anywhere in my code. We also have U8, U16, U32, and U64. And the U type just means it's only positive numbers, and the I type means also includes the negative numbers, right? So it's really easy to understand, right? Like if I do x equals to U8, and I'll give it a 5. So this is a U8 type. A U8 is just 8-bit. A U8 just means 8-bit, right? And U16 means 16-bit. And also the U32 just means 32-bit. 64 means 64-bit. Yeah, that's it. It's easiest type in Rust programming language. And by the way, we have to, in Rust, if you are learning Rust, you have to understand the stack and heap, the difference between stack and heap in memory, because you have to understand it to understand like references and ownerships. So everything's just based on the your understanding on stack and heap, the memory basics. But everything right here, you can, like if I do like that x call U8 equals to 5, this x right here, it is stored in stack, right? It is stored in stack. And if you want to take a if you want to know if you want to know something that is stored in heap, I will give you an example, like that y, this is the string type, equals to string new, right? String from, string new is the same thing. From is just implemented trade. I will talk about trade later also. From right, it can be an empty string though. So right now the y, it's a pointer on the stack that points to the actual data that's stored in heap, which is the empty string right now, right? So y is in the stack and x is in the stack. X is the actual data because it's a 5, it's a U8 type, it's an easy type. But for now, y is also on the stack, but y is a pointer. I think it's 24 bytes because it's a struct on the stack, but for now, the only thing you have to understand is that y is on the stack. It's a pointer on the stack, points to the actual data that is in the heap, which is a empty string. So the reason why it's designed that way, because everything, so there's something you have to remember in every programming languages. It's the same thing, because for almost every programming languages, if it's compiled language, stack stores everything uh, that size have like certain size that in compile time. So since the a string type, you have to like dynamically add things into this string, or like let's take another example, like a vector. I don't know, u32 string vector. Oh, vac. Sorry. From like 9, right? So this vector is also a pointer that points to the actual data in the heap, because for these two types, the reason why it stores it on the heap because it's dynamic, right? You cannot know the actual length of the data uh, for it before it actually runs the program. The computer wouldn't be able to know that, because you can define other things in different functions that you want to operate for the vector and the string things, right? It just don't, the computer just don't know why, where, how long is the actual data, so we have to store that on the heap. uh, I think that makes sense for most of the guys. And also, stack is much more faster, much more faster, right? And much faster, much faster. Yeah. So that's basically everything you have to understand. And for and also, yeah, like for example, if I want to add something to X, there is absolute no way for me to do that. But if I want to add something to Z, I can do that. I can. It's totally acceptable. You can use Z dot push. You can push it like a 6. It's okay. It's just okay. And now we have another problem, which is let's we if we wanna modify it, we have to make something mutable, right? We have the mutable keyword, right, in the Rust programming language. So you have to make it mutable to actually make it to change it, right? And it's easy too. Uh, and that's everything for today. Be sure you understand the a stack and heap thing. Uh, it's not hard, but it's necessary to understand. And next class, we'll talk about the ownership and the borrowing system, which is really unique for Rust, and is actually the only. I wouldn't say it's the only programming language. It's one of the. It's just really unique for Rust, and it actually save, and the ownership and the borrowing system just is the really big factor that affect the memory. And it also saved the, so every people said, every single person, like I have ever met said that like Rust is more safe types memory safe than C++ or C, and the ownership and the borrowing system is the reason why it is really safe. So if you guys want to understand the next class, you guys have to understand everything that is happening on the heap and stack, and just, yeah, be sure you see you soon. Be sure you understand all of that shit. Yeah.